How's it going, Math 1 people? This is lesson 6.3, Simplify Square Roots. In Khan Academy's Math 1 section, we are working in the exponents and radicals unit. And after this lesson, you'll be able to complete skills 7, 8, and 9 in that unit. Your objective is that you'll be able to rewrite expressions involving radicals and rational exponents using properties of exponents. So we have a product property of radicals, and I just want to take one step back to show you that this really isn't anything new. This is a different version of the product to a power rule that we saw in lesson 6.1. The only difference is when we were in 6.1, our exponents were integers, but you should know that this product still holds when our exponents are fractions. So the square root of AB, that's AB to the 1/2 power, and because of this property, we know that we can split that. We can say it's A to the 1/2 times B to the 1/2, which is just the square root of A times the square root of B. This is really nice. This is going to help us simplify square roots. So to simplify, we're going to use the product property with our trusty perfect squares number line. Here's our number line. It has the numbers 0 through 15 on it, but it also writes each of those integers, 0 through 15, as a square root of a perfect square. So the square root of 16 is 4, the square root of 25 is 5, the square root of 36 is 6, and so on. So if I ask you to simplify, like in example 1, it says the square root of 12, we would follow these 4 steps. First thing we do is write out our perfect squares number line. As you get more practice with this, you may not need to write out the number line, but you should at least be very familiar with your perfect squares, okay? Step 2, we're going to start at the number given in the problem. Start at 12, and we're going to check 12. We want to check each perfect square to see if it's a factor of 12, rather. So is 225 a factor of this number? And really, we can skip all the way down to, we can skip all of these, because 16 through 225, those are all bigger than 12. They're not going to be factors of 12. 9 is the first perfect square that is less than 12. And if we ask ourselves, is 9 a factor of 12? It's not, right? 9 does not go into 12 evenly, but 4 does. So that's what we did here, is we found a perfect square that's a factor of 12. It's 4. We're going to write that number under the radical. So we draw a radical symbol, put the 4 there. The next step is to write the other factor second under the radical. So not only do you need to recognize that 4 is the biggest perfect square that goes into 12, but you also need to know 4 times 3 is 12, right? So we're just factoring 12 as a product of 4 and 3. The last step is to simplify the first factor written. So this first factor, 4, it's a perfect square. So it's always going to simplify. The square root of 4 is a 2. And then we're done. We have 2 root 3. This is the simplified form of the square root of 12. And the reason we know we're done is because 3 doesn't factor any further. There's no perfect square that could be factored out of 3 other than 1. And if we factored a 1 out, it would still stay a 3. It wouldn't get any more simplified. So we're done. Let's try the same process with example 2. So we have the square root of 98. So the square root of 98 equals, we're going to scan our number line for the biggest perfect square that's a factor of 98. So these are all too big. Is 81 a factor of 98? No. Neither is 64. But 49 is. In fact, 98 is 49 times 2. So we just completed Step 2, because we checked for a perfect square and we wrote that number under a radical. We also did step 3 because we wrote the other factor. Once we identified 49, we found out that 49 times 2 gives us 98. And then our last step is to simplify that first factor. We're going to use that product property to split it into 2 square roots. The square root of 49 times 2 is the same as the square root of 49 times the square root of 2. But we know the square root of 49 is 7. So our final answer is 7 root 2, or 7 times the square root of 2. Let's try example 3. And in fact, I'm going to make a mistake on purpose for this one. Let's say we've got the square root of 200. Now, according to our steps, we would look at our number line and try to find the biggest perfect square out of these green ones that's a factor of 200. And we should get 100 as that biggest perfect square. But let's say I forgot that. Maybe I forgot that 100 doesn't really go into 200. So I keep going. 81 doesn't go into 200. Neither does 64 or 49 or 36. But 25 goes into 200. So let's say I don't pick the biggest perfect square, but I say 200 is 25 times 8. You can check my math. That's correct. 25 times 8 is 200. I still use my product property. That's 25 times the square root of 8. And the square root of 25 is 5. I did not write anything that's untrue here. This is still true. The square root of 200 is equal to the square root of 5 times the square root of 8. The only problem is the square root of 8 simplifies further. If I try to repeat the process and simplify the square root of 8, we will find, I'll just keep it the same color, that the biggest perfect square that goes into 8 is 4. So I could rewrite the square root of 8 as the square root of 4 times 2, which would be 5 root 4, 5 times the square root of 4 times the square root of 2, but that's 5 times 2 times the square root of 2, which would be 10 root 2. The whole point is, even if you don't pull out the largest factor, you can still keep going to get to the right answer. This is not a wrong answer. This is just not fully simplified. 10 root 2 is fully simplified because the square root of 2 cannot be simplified further. The square root of 8 can, because we could bring out a factor that's a perfect square. So just so you have the right way also, or the quickest way, not that this is wrong, but the quicker way, if we had noticed that 100 is the largest perfect square that's a factor of 200, then I could square root 100, I could square root 2, and the square root of 100 is 10. So I get 10 root 2 without as much writing as I did here. All right, last one, example 4. We have -4 times the square root of 300. Again, we're scanning our number line for perfect squares that are also a factor of 300. I think it's going to be 100 again. So we can rewrite 300 in the radical symbol as 100 times 3. And according to that property we wrote at the top of our page, that's the same as -4 times the square root of 100 times the square root of 3, which is -4 times 10 times the square root of 3. And I know -4 times 10, that's -40. But the square root of 3 just has to stay there. All right, try practice problems 2, 3, and 1, 2, 3, and 4 on your own, and come back and check your work. All right, practice problem 1, we have the square root of 33, and sorry, this was kind of a trick question. If you go through your list, there are no factors of 33 that are perfect squares. You can go back up to your number line. 36 is too big. 25 does not go into 33. Neither does 16, neither does 9, and neither does 4. So there is nothing to simplify. That's not the case for number 2, though. The largest perfect square that's a factor of 1,000 is 10. So we can split that up into 2 square roots, and we know the square root of 100 is just 10. So our final answer is negative 10 times the square root of 10. In practice problem 3, we have 10 times the square root of 108. The largest perfect square that's a factor of 108 is 36. So we can rewrite our expression this way. The square root of 36 is just 6. And then we need to multiply the numbers outside the radical. We'll get 60 root 3 as our answer. Last one, we have 18 inside the radical. If we go through our perfect squares number line, 9 is the biggest perfect square that's a factor of 18. So we split it up, and the square root of 9 is 3. Multiplying the numbers outside of the radical sign, we get 6 root 2 as our answer. And that is it for lesson 6.3. We did not practice any simplifying when there's variables involved, so we are going to go into the practice here just for a question. I want you to try this one as well. You'll see this in Desmos, but the idea pretty much stays the same. We're going to rewrite this as the square root of the 54 part is exactly the same. If you look through your number line, for the largest perfect square that's a factor of 54, it should be 9, because 54 is 9 times 6. The other thing we need to look at is this x to the 7th. Really, when you have a variable like x or any other letter, if it's raised to an even power, it's a perfect square. To show you why, like x squared is just x times x, right? But x to the 4th, isn't that just x squared times x squared because you add exponents? Or x to the 6th would be x to the 3rd times x to the 3rd, so that's a perfect square. Even x to the 100th, it's a perfect square because it's x to the 50th squared, right? So we can rewrite this x to the 7th as the perfect square part, x to the 6th, times one more x. Remember, that's like x to the first power, but we usually don't write that 1. There we go. And then I can still, since it's all multiplying, I can break this up into lots of radicals. This is the square root of 9 times the square root of 6 times the square root of x to the 6th times the square root of x. And then the one extra trick I'm going to show you is that it's all multiplying, so you can change the order as well. I'm going to rewrite this as the square root of 9 times the square root of x to the 6th, and then I'll put the stuff that doesn't simplify at the end. Like the square root of 6 won't simplify. The square root of x is just going to stay square root of x. But the first two parts are perfect squares. The square root of 9 is 3. And the square root of x to the 6th is x to the 3rd. Remember, this is x to the 6 over 2 power, right? So I could put that intermediate step if you're not sure what that would be yet. But remember, this is a radical symbol with the index missing, so that means the index is 2. So we will end up with x to the 6 over 2 power, but 6 over 2 is 3. And then the rest of it just stays. In fact, we can go back and put the 6 and the x in one radical symbol. once we know nothing else can be brought out. That would be our answer. All right, that's lesson 6.3. As always, ask a question, and I'll see you all in the next video.